Okay, welcome back to the channel. Now today we're looking at some more algebraic fractions, but eventually what we're going to do is introduce something called partial fractions. And so what we've learned so far is how to combine two of these fractions together to give us one big algebraic fraction at the end. So that's what we're going to do to begin with. So I just want to combine these. And so we should know by now that our common denominator is going to be x and x plus 2 and x and x plus 2. And so the top of the first fraction is going to be x plus 2, and the second one there just 3x. And so we can collect this all together and we have 4x plus 2 all over x and then x plus 2. So what we know how to do is start with two of these algebraic fractions and bring it into one big algebraic fraction. But now what we've got to learn is if we're presented with this fraction here, how we turn it back into two separate fractions. And so that's what we need to look at. So I'm going to take this, let's just rewrite this over here for now. So we've got 4x plus 2 over x and x plus 2. And what we want to do now is turn this into something over x plus something over x plus 2. So that's what we need to do now. Now, in order to put these two fractions together, we already know that there needs to be a common denominator. So for this to equal this, we'll need to make the first fraction have x and x plus 2 in its denominator. And for that to be the case, we need to times the top by x plus 2. Now for the second fraction, which was just this, again, we need a common denominator, so we need to multiply this by x and the top by x as well. So now this, if I add this together, should be the same as our big fraction over here. So now what you can see is the denominators are all the same in all of these three fractions. And so all we really need to do now is compare the tops of the fractions. And so what I can say is, I'm going to simplify this and just concentrate on the tops. So this. And now what we can do is pick, some x values to try and help us find out what a and b are actually going to be. And so the first thing I'm going to do is I'm going to say let x equal 0. And so what happens if we do that? Well, 4 lots of 0 is just 0 plus 2. So we just end up with 2 on this side. Now have a look at the other side. We've got 0 plus 2, that's 2 lots of a, so equals 2a. Plus, and b times 0, well, is just 0. So in fact, we don't even need that there. Let's just get rid of this. So now we've got 2 is equal to 2a, which means a must be equal to 1. And now what we can do is say, well, I want to let x equal minus 2. So why did I do this? Because if I have x as minus 2 here, minus 2 plus 2 will give me 0. So we'll cancel out the a completely. So we'll start on the left. 4 lots of minus 2 is minus 8, plus 2 is minus 6. Now, as we already said, if I put minus 2 here, minus 2 plus 2 is 0. 0 times a, 0. But put minus 2 into this x, and we've got minus 2b. So minus 2b. And so that means, divide that across, b is equal to 3. So if we go back to our fractions that we laid out, we've just said that a, this one over here, is apparently equal to 1. And b, this one over here, we said is equal to 3. And if we have a look back at the two original fractions that we had 1 over x and 3 over x plus 2. And so that there's a brief intro to partial fractions, and if you have one big fraction, how we can then separate them into the two smaller fractions that they came from. Now, in the next video, we'll look at a few more difficult examples, and then maybe one where we have maybe 3 fractions in the denominator. So stay tuned, and I'll see you in that video.